All right, now on to Unit 3, Part 2, Computing Truth Values. So we've looked previously in the first part on how to just kind of what are the rules for computing truth values for each of the 5 sentential operators. But remember, since sentential logic is truth functional, you can figure out the truth values of really complex formulas if you know the truth values of its component parts. So what we're going to do now is put together what we had in the last lecture, and we're going to figure out how to compute the truth values of complex formulas. So recall at the beginning of part 1 where I indicated that you would be able to compute the truth values of fairly complex compounded sentences such as this one right there. And you're probably pretty intimidated. Well, we're going to walk through this lecture how to do that. What I'm going to do though for this lecture is I'm going to walk through the examples given in the book, but I'm going to explain them slightly differently. So the book walks you through how to compute the truth values of 4 different formulas. And I'm going to do just that. Oh, I guess I have an email. But I'm going to do it a little bit different way than the book does it. So not 100% different, only slightly different. Just, but for your benefit. And the idea is then that maybe you might like my approach better, you might like the author of the book's approach better, whatever. But there's good pedagogical value in teaching the same thing 2 different ways. So that's what we're going to do. First, some assumptions. In any of these forms, so A, B, and C stand for simple declarative sentences, as does X, Y, and Z. A, B, and C will all be true in the following formulas that we look at, and X, Y, and Z will all be false in all the formulas that we look at, as the book says. Well, we'll start with a simple formula. Let me get the pointer ready. Okay. Not A or not B, then not C. If not A or not B, then C. And recall that the arrow is the same thing as the horseshoe. The book uses the horseshoe, and about half the time I'll use a horseshoe, but sometimes I'll use the arrow. The arrow is the conditional, just as the horseshoe is a conditional, okay? So just have that in your mind. All right. If not A or not B, then not C. That's a simple formula. How are we going to compute the truth values of that? Well, the first step in computing the truth values is pretty easy. Just mark a T for true above any of the letters which we assume to be true, which is A, B, and C. Likewise, mark an F for false above any of the letters that you assume to be false, which is X, Y, or Z. All right, so see, A is true, so we mark A is true. B is true, so we mark B is true. C is true, so we mark C is true. First step. Second step, just work your way to one level more complex. Mark each slightly more complex component with a T for true or an F for false, depending on if the component sentence is true or false. At this stage, you'll be dealing with compound rather than simple sentences, so you have to refer to the truth tables in this case. So, well, the next level up in complexity uses sentential operators, but it uses a negation in all 3 instances. Well, remember the rule for negation? If A is true, then the negation of P is false. If B is true, the negation of B is false. If C is true, the negation of C is false. But remember, we've only gone up one level in complexity. So we went from A to not A, B to the negation of B, C to the negation of C. We're not going to any more complex than that for this second step. And that's basically, for every step you go through in this process, you just go to one level more complex. You never go any more than that. All right, well, that's the second step. That was also pretty easy, especially because the next level of complexity was just simple negations. Well, the next step, as I said, is similar to the second. Just move up one level in complexity and compute the truth values for the next most complex component sentences. All right, see what I've done here. See these parentheses right there? That's so once we figured out the negation of A's truth value and the negation of B's, they're both contained within these parentheses, and there's a disjunction operator. So we'll just move up from there. Well, remember the rules for the disjunction? If both disjuncts in a disjunction are false, then the disjunction as a whole is false. Remember, if both disjuncts in a disjunction are false, the disjunction as a whole is false. All right. Well, that was the next level of complexity. Well, and I just stated this rule, so I won't read it. It's on this slide. The final step is similar to the second and third steps, and it's pretty much always the same. You just move up one level of complexity. Since this formula is fairly simple, the next level of complexity will take us to the major operator in the formula. Well, once you figure out the truth value of the major operator in the formula, you figured out the truth value of the whole formula. Well, the major operator is this conditional sign. Remember, the arrow is the same thing as a horseshoe. The book's using a horseshoe, I'm using an arrow. It's the same thing. So, what are the rules for conditional? Well, this should be easy. If the only time a conditional is false is when the antecedent is true, that is what goes to the left of the arrow or horseshoe, and when the consequent is false, that is what goes to the right of the arrow or horseshoe. Well, the consequent in this formula is false. But the antecedent in this formula, this is the antecedent, by the way. And remember, we calculated the truth of the antecedent, and it's false. So, this is a true conditional. And remember another rule of thumb. Anytime you have a false antecedent in a conditional, the conditional as a whole is true. That's another shortcut. So, recall, there's only one time a conditional is false, and that's when it has a true antecedent but a false consequent. This conditional does not have a true antecedent. It's got a false antecedent. So this conditional is true. So that's the truth value for the whole formula. Again, you work your way up in stages. You start with the letters. You move to the next level of complexity. Then you move to the next level of complexity. And you work your way up just one level of complexity at a time until you get to the major operator. And then, once you figure out the truth value of the major operator, you figure out the truth value of the whole formula. And this formula is true. Well, again, since the major operator is a conditional operator, the antecedent is false, the consequent is false, the formula as a whole is true. Well, let's move on to a slightly more complex formula. Okay, another thing. If IFF stands for if and only if. It's another shorthand of logicians. When you see IF, not IF, but IFF, that's the same thing as the biconditional. Okay, that triple bar. If and only if. Alright, so for this lecture I'll be using IFF, and that's just the biconditional. If and only if. Alright, so here's a slightly more complex formula. Take a look at it and scan it first. It's got several different operators. It's got a negation, it's got a biconditional, and it's got a conditional. So we've got three different sentential operators that we're dealing with in this sentence. So you're going to have to know the rules for three different sentential operators. But hopefully you've memorized it by now. Alright, well, the first step in figuring out the truth value of this compound formula is the same as the first step in the previous one. Simply mark T or F over each letter. Recall that A, B, and C are to be marked true, and X, Y, and Z are false, so mark them as F. Boom. Okay, A is true, Z is false. A is true, Z is false. We're just doing the letters. We don't have to do anything more than that. Well, what's the second step? Again, just move up to one level of complexity and then figure out the truth value at that next level of complexity. Well, the next level of complexity we can find in this formula contained within the parentheses. There's negations. Right there, right there. And remember the rule for negation? If A is true, then the negation of A is false. If Z is false, the negation of Z is true. That's it. Boom. Second step done. Well, let's just move up to the next level of complexity then. IFFs, if and only ifs, biconditionals. Remember, the IFF is the same thing as that triple bar. If and only if. What is the rule for the if and only if, the biconditional? Well, I remember how I say they stand or fall together. So either they both have to be true or they both have to be false. If both are true or both are false, then the biconditional as a whole is true. On the other hand, if one or the other is true and the other one is false, in other words, the left and right side of a biconditional do not have the same truth values, then the biconditional as a whole is false. Well, since not A is false, but not Z is true, this biconditional, since the left and right side have different truth values, is going to be false. Okay, well, since A is true, and since F is false, this biconditional as well is going to be false. So we've got a false biconditional here and a false biconditional there. All right. So this slide just basically states what I just told you, so I won't read it. You know what the next step is? Again, move it to the next level of complexity. All right. Now there's some parentheses in here, so we need to figure out what the next level of complexity is. You might think it's this negation operator, but look how many parentheses are there's right there. And then let's move to the next complete set right there. But then let's move to the one size bigger right there. See? Well, that negation operates on everything in these parentheses. So that is the major operator. Well, you're correct in to think that. All right. Well, then the next level of complexity is not the major operator because we still have this conditional operator. Remember, the arrow is the same thing as a horseshoe. So we don't need to figure that out. First, we need to figure out the truth value of this conditional. Okay. Well, the antecedent is false. Well, remember, anytime in a conditional the antecedent is false, the conditional as a whole is true. All right. Again, the only time a conditional is false is when it has a true antecedent and a false consequent. Since this conditional has a false antecedent, it's true. All right. Again, since the antecedent and consequent of the conditional are both false, the sentence is false. So, I guess we're done, right?
Wrong, 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 wrong. Wrong, 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 wrong. You're wrong, you're wrong, you're wrong.
Remember, the major operator of the formula is not the conditional. Again, look at the formula as a whole. That's the major operator, that negation sign. So that is what we need to figure out the truth value of. Once you figure that out, then you'll know the truth value of the formula as a whole. But it was not the conditional. Since the conditional was true, the formula is in fact false. Remember? This conditional was true, but it was not the major operator. And a negation just, if something is true, the negation of it is false. Since everything in the parentheses is true, the negation of everything in the parentheses is false. Boom. Well, let's move up to an even more complex formula. First, let's just take a scan at it. I see negation, I see a disjunction, I see a conditional operator. Remember, the arrow is the same thing as a horseshoe. See another disjunction. So we got 3 sentential operators in this formula. All right, you should know the steps by now to calculating the truth value of this complex formula. First, mark the individual letters as true or false with a T or F, respectively. I did that for you. You're welcome. A is T, B is T, Z is false, B is true, Z is false, A is true. All right, well, what's the next step? Again, we'll just move on to one level more complex. Well, we'll start with this. A is true and B is true. Since A or B is a disjunction, and recall, in disjunctions, if both disjunctions are true, then the disjunction as a whole is true because it's an inclusive disjunction. All right. The next formula is again another disjunction, B or Z. Well, if one of the 2 disjuncts in a disjunction is true, the disjunction as a whole is true. Well, since B is true, the disjunction B or Z is, you guessed it, true. Finally, there's the negation of A. Well, since A was true, the negation of A must be false. All right. That was pretty easy. Let's just move to the next level. Okay. First, we got this conditional. Well, remember the rule that the only time a conditional is false is when the antecedent is true and the consequent is false. Well, the antecedent of this conditional, right there, is true, and the consequent is false. So, this conditional is false. All right, we have another conditional. Remember again, the only time a conditional is false is when the antecedent is true, but the consequent is false. Well, the antecedent in this conditional is true, and the consequent is false. So the conditional as a whole is false. Okay, well, let's move to the next level of complexity. This next step's tricky, though. What is the next level? We've got two operators left. We've got this negation operator, and then we've got this disjunction operator. Well, the trick, and you saw this in the book, is you can just start drawing lines into the parentheses. So we got that, and then we got that, so that's one whole unit. We've got that, and we got that, so that's one whole unit. Well, what's this negation operating on? Well, since this parentheses begins here, but then it ends here, the negation's operating on this right there. It's not operating on all of that, it's operating on the left side of that disjunction zone. So, the next level of complexity then must be, what is it? It's that negation sign. All right. So, since what's being negated basically makes the truth value the opposite of what was previously, and everything in these parentheses is false, the negation of what is false must be true. All right. Well, what does that leave us? It leaves us with the major operator. Okay. Well, it's a disjunction. What's required for a disjunction to be true? All that's required is that one of the disjuncts be true. Well, since the left disjunct is true, the disjunction as a whole is true. All right. Now on to a really complex compound sentence. First, let's take a look at it. We got negation. IFF, remember that IFF is the biconditional. It stands for if and only if. We have a disjunction. See that ampersand? That's the same thing as the dot. You should know what that means, though. That's a conjunction. Okay. We have another conditional operator. Remember, the arrow is the same thing as a horseshoe. And then we have a disjunction. So this has got all the symbols, I think. Yeah, this is every single sentential operator. So it would really come in handy to know the rules for each of the 5 sentential operators. It makes figuring out the truth values of complex formulas like this go a lot more breezily. All right, well, we know the first step. Put a T or an F above each letter respectively. Well, A is true, B is true, C is true, X is false, Z is false, Y is false. Okay, all we do next is move to the next level of complexity. The negation of A is false because A is true. Then we have a disjunction right there. Well, it's an inclusive disjunction, as all the disjunctions are in the class, so since B is true and C is true, the disjunction as a whole is true. Okay. The next level of complexity is in these parentheses right there. It's a disjunction as well, but both disjuncts are false. Well, in that case, the disjunction's got to be false. Okay. Well, what's the third step? Just move up a level in the complexity. All right. First level. We got these parentheses, but then we got these parentheses. So that would be the next level of complexity. We've already figured out the truth values of this negation and this disjunction. So it's an if and only if conditional. Remember, that's a biconditional. It's the same thing as the triple bar in the book. Okay, well, what are the rules for the biconditional? They stand or fall together. Both sides of a biconditional have to have the same truth value if the biconditional is to be true. Well, the left side is false, the right side is true. So the biconditional's got to be false. All right. What's the next level of complexity after that? Again, draw lines in the parentheses. Okay, so that'll be the next level. It's a conditional. Remember the rules for conditional? The only time a conditional is false is when it has a true antecedent and a false consequent. Well, this does have a false consequent, but the antecedent is also false. Well, the conditional is true. Here's another shorthand. Anytime a conditional has a false antecedent, the conditional is true. So that should be a shorthand. So, next level of complexity. False and true. Next level up after that. Well, the question is, what is the next level? All right. Again, draw those lines. Draw those lines. We've got three operators left. We've got this negation, we've got this conjunction, and we've got this negation. Okay. Well, let's start on the right side. What is this negation operating on? It's operating on everything between this parenthesis. It can't be that one. So it's got to be this guy right there. All right. So this negation only operates from here. All right. I think that's going to be the next level of complexity. Yep, I was right. Gosh, I'm good at guessing what my next move will be. Okay. Well, what are the rules for negation? What's being negated is true, so the negation of what is true must be false. And it is. Logic is very predictable, unlike the weather. Okay, well, what's the next level after that? We've still got two symbols left. We've got, it's the conjunction. Why? This negation is operating on everything between this bracket and that bracket. So, that is not the next level of complexity. That's the final level of complexity. That's a major operator. The next level of complexity is just conjunction, right there. Well, what's the rule for conjunction? There's only one time a conjunction is true, and that is when both conjuncts are true. Well, what's being conjoined? Well, the left side of what's being conjoined, this formula right there, it's false. So we know the conjunction is false. We don't even need to look at the right side. We know that since the left thing being conjoined is false, the conjunction as a whole is false. And it is. All right, now we can do that last move. We got this negation operator, which is the major operator of the formula. Well, what's being negated is false. And if what's being negated is false, then the negation must be true. And it is. See? It doesn't matter how complex a formula is. You follow the same steps, and you can figure out, as long as you know the truth values, and as long as you know the rules for the sentential operators, and you know how to move from one level of complexity to the next, figuring out the truth values of these complex formulas is actually pretty easy. And if you practice, which there's a million exercises in the book, and practice, it gets easier and easier as you practice it. And that's what I encourage you to do.